Hello Matrix, welcome to another lesson of science, and today we are going to do organic chemistry, and specifically we're going to lay some foundations. So we're looking at naming organic molecules because that's really important. You can't do anything else until you name them. So what we're going to start off with is we're going to look at some of the important terms, and I've got a list of hydrocarbon, homologous series, functional group, saturated hydrocarbon, unsaturated hydrocarbon. And what I want you to do quickly is just for 2 minutes discuss what you understand about what these terms mean. Okay, so I'm giving you 2 minutes, off you go. So, grade 12s, how do you think you did? Hopefully you did okay. Let's have a look at those terms because these are definitely the ones where you're more likely to get in an exam. So if we start with a hydrocarbon, this is when we recognize that this is an organic compound. Okay, so here the first thing is that we have to recognize that it's an organic compound. It's not just any compound that has carbons and hydrogen atoms. Okay, that's H. So a hydrocarbon is an organic carbon that has only carbons and hydrogen atoms in it. Okay? A homologous series, and I hate these words, I can't pronounce them on a good day, is a family. All right? So I like to describe it as a family of compounds, and what we mean by that is that they are a group of organic compounds that have the same functional group, okay, same general formula, okay, let's just, there we go, same general formula, as well as they only change from each other by a CH2 molecule. Okay, so for every part in the series, we add a CH2, makes it longer and longer. Okay, so that's your homologous series, and this is what we're going to focus on today. Your functional group is is an atom, okay, or a group of atoms that determine the chemical properties of the organic compound. So it can be the bonds as well, it could be halogens, it can be oxygens. Out of school, if you carry on with organic, you can realize that it can be things like nitrogen, sulfur. We don't do that at school level. We just stick with the oxygens and we keep with carbons because it makes life a bit easier. Okay, so your functional group is your atom or group of atoms that give that particular compound its chemical properties. Okay, a saturated hydrocarbon is a hydrocarbon that only has single bonds, but be careful here, between carbon atoms. This is really important because sometimes we get confused with some of our functional groups because they have double bonds in them, but it's between a carbon and an oxygen. So that doesn't really help us in terms of saturation, okay? So saturated hydrocarbons, single bonds between carbon atoms. Unsaturated is double or triple, okay? So there's double or triple bonds between carbon atoms. Okay, so now that we've got our important terms, we need to actually look at our different functional groups. It's really important. Luckily, we've only got about 8 or 9 that we need to learn, and that's okay, so we can actually get there. So before we get there, I forgot about this, we need to be able to write and name properly. So there's lots of ways we can write a formula and explain what we've got. So I'm going to use an example to help you here. First one we're going to do is hexanol with an OL in it. Okay, now the molecular formula you've done before. You've done lots of molecular formulas. Molecular formula C6H14O. That means that I've got 6 carbons, 14 hydrogens, 1 oxygen. Condensed formula shows me structure. So molecular formula only tells me how many of each atom we have. Condensed molecular formula tells me a little more about its structure. So this condensed formula is going to be CH3, then it's going to be CH2. So now we've got 2 hydrocarbons. That's 3. Oh, no, that should be a 2. Oh, see, even I make mistakes, so that should be a 2. Let's go back there. Okay, so so that's 3, that's 4, that's 5, and then my 6th one looks like that. So this is condensed. It doesn't look very condensed, but it is. It shows me structure, shows me that the OH is at the end, shows me where my single bonds are, all of that sort of thing. So what I'm going to ask you to quickly do, so I'm going to give you a minute to do this. I want you to draw the structural formula of the hexanol. So you've got the condensed formula. You now have a minute to draw the structural formula. Off you go. Okay, so let's see how you did. So what we have here, so we have hexanol, so we have CH3. All right, so that tells me that there's my CH3. Then we have a CH2. Okay, so that's 2. This is my 3rd one. This is my 4th one. This is my 5th one. And hex means 6, so I know there's 6. And here's my 7th one, 6th one. 1, 2, 3, that's 6. And then we have the OH. So there's a couple of things I want you to notice. Number 1, each carbon only has 4 bonds. Can't have more, can't have less. Okay. Here with the OH, we're going to deal with that in more detail. It has to be, you have to show the covalent bond between the oxygen and the hydrogen. Very, very important. And with structural formula, you show me exactly what the molecule looks like. Okay. So you show every bond, you show every hydrogen, you write everything in. This is actually far more useful than the condensed structural formula. Okay. So what we now need to look at is the functional groups, and you've got a few. So we're going to just talk about them a little bit, all right? And sort of look at an example as we go along. The first one is our alkanes. Those are our simple ones. And if we use butane as my example, butane looks like this. So there's C4, okay? And we have all the hydrogens around it. And what's important here is that the carbons only have single bonds between them, so that's how I know it's an alkane, because of the single bonds. General formula, CnH2n plus 2, so for every carbon we multiply, to get the number of hydrogens, we multiply the number of carbons by 2 and we add another 2, that tells me how many hydrogens I have, okay? The next one are our alkenes. Alkenes must have at least one double bond, okay, and my example that I'm using is but1ene. So my double bond sits over here, and what's important is the hydrogens sort of go off at the side. That first carbon can only have 2 hydrogens, can't have 3, otherwise it's making 5 bonds, and it can't make 5 bonds. This middle carbon can only have 1 hydrogen, otherwise it's also making 5 bonds. I actually don't have enough carbons yet, so let's just put in the last one, which is shrunk a little bit, but that's okay. But1ene, it is unsaturated because of the double bond between the carbons, and it's the general formula is CnH2n. That means for every carbon I have twice as many hydrogens. These are still basic hydrocarbons. We haven't done anything exciting, haven't put anything exciting in them. The next one is but1ine. So but1ine means that I have a triple bond. Okay, now this carbon at the end can only have 1 hydrogen, which we put off the end because of what we learned last year about Vesper and the molecular geometry we did last year. This middle carbon can't get any hydrogens, otherwise it makes more than 4 bonds. Okay, that just went off to the side. Let's not do that. It really should be here, nice and neat, or as neat as you can do it. And sometimes we know I'm not that neat. So there we go. We've got our triple bond. It is a saturated hydrocarbon because it's got a triple bond between the carbons. General formula, CnH2n minus 2, which means to work out how many hydrogens I have, I take the number of carbons, multiply by 2, and then minus 2 from that. Okay. Then we get to the next functional group, which is your haloalkanes. And a haloalkane means that it has a halogen in it. And the functional group is carbon bonded to an X. Now, the X represents any of the halogens, fluorine, chlorine, bromine, iodine. We'll talk about the naming in a second. So here, my example is chloro is 1 bromo, 2 chloropropane, which looks like that. And basically, in place of a hydrogen, I have placed a halogen. Okay, so it's my haloalkanes. Alcohols, very important. Their functional group is the hydroxyl group, not a hydroxide. It looks like a hydroxide, but it's not. Okay, so if we've got butane 2-ol, so I'm going to put it here. We always show the bonds, and so in place of a hydrogen, what we're going to put there is we're going to put the OH in place of it. Okay, so these are nice and simple. We haven't done anything too exciting here yet. Carboxylic acids get a little more complicated. My carboxylic acids have the functional COOH. Now, when we draw that, it actually looks like this. So this is known as a carbonyl group, okay, because we have a carboxyl group, sorry. So we have the double bond to the oxygen. So ethanoic acid looks like this. Ethanoic acid, you all know, it's vinegar, okay. So this is what ethanoic acid looks like. Oh, no, I was about to give carbon an extra bond, and hopefully some of you are going, wait, Tracy, you can't do that. So there we go, ethanoic acid, nice and simple. Then we have esters. Esters are a little more complicated. We're not going to spend too much time on esters today. And my bond actually looks like this. This is the functional group, where this could actually be, sorry, that has to go to a carbon. So there's the carbon. Oh, no, I'm just adding things in because I can. Look at that. Okay, and whether this goes to the end or goes to another carbon depends on the functional group, okay? And this one that I've got here, if we change this to methyl ethanoate, it means I have to put another one here. So that's the ethanoate part and that's the methyl part. The thing about esters is that they are responsible for all nice smelling things and in artificial smells, even real smells, okay, fragrances, perfumes, foods, all of those sort of things. It's great. Okay, now we've got 2 more to go to, and that's ketones and aldehydes. Now, ketones have a carbonyl group, so ketones have a double bond to an oxygen. What's special about a ketone is that this bond must sit in the middle of it. So if we look at propanone, I don't need to put numbers, we'll do the number, that's propanone. All right, so ketone sits there, all right. when we look at an aldehyde, it looks almost the same, but with an aldehyde, that double bond has to go to the end. So this, when I put the double bond oxygen on the last carbon, that turns it into propanol, okay? At the end, not at the end. So ketones, the double bond's not at the end. Aldehydes, the double bond must be at the end, okay? So now we're going to take a short break, and then when we get back, we're going to see how much of what I just did in the last 10 minutes actually sunk in. So we'll see you in a little bit, and then we'll do a question. All right, welcome back, grade 12. So you've had a little bit of a break, given your mind a bit of a rest, and now we're going to see how much went in. So I've got a question for you, and what I've got here is a set of compounds, and you can see them. Okay, I'll move it up as I give you time. And what I want you to do with these compounds is you need to identify the functional group. So you want to draw the functional group out for me. And I want to know what group it belongs to. Is it an alkane, alkene, alkyne, etc. Okay, so you identifying the functional group and you just identifying the homologous, hate that word, series, the family it belongs to. Okay, so we're going to do this one quite quickly. So I'm giving you 2 minutes, see how far you get, and your time starts now. So grade 12s, let's see how you've done. All right, so over here, the first one, if we look at it, what's important, this here is my functional group. That's a bit thick, so I'll do another one. All right, it's got the OH, it's the hydroxyl, which makes this an alcohol. Okay, let's just make, I'm just going to make my pen a little thinner because it's a bit thick there. Okay, now, oops, next one is if we look at it and we go fine. Now, the next one's over here. This there is my functional group, and that makes this an ester. Okay, so there we've got an ester. Over here, we have a double bond to an oxygen. Now remember, we have a choice here. It's either a ketone or an aldehyde. And because it sits at the end of the chain, that makes it a ketone. All right, so there's my ketone. And over here, we look at D, and D, we have a double bond between the carbons. Double bond between the carbons makes this an alkene. All right, how are you doing so far? Hopefully you're going, yes, we got this. I hope so, because this is important. Then over here, we have a triple bond between the carbons. That makes this an alkyne with a YNE. All right, now look here, there's a double bond between the oxygen, and hopefully you can see the difference between C and F, because C, remember, it's got the double bond to the oxygen at the end. I was wrong. Somebody's screaming at the TV right now. That's not a ketone. It's an aldehyde. Okay, so now hopefully someone's going to, but Tracy, how do you remember what the difference between the two are? Because that's quite important. This one's the ketone with the double bond not on the end, is I like to remember it this way. Hopefully in your life sciences biology labs, if you have one, which I really hope you do, you've seen that sometimes there's those specimens, or you see on TV and they keep specimens of things. Ours has some really gross ones. That's why I don't go into the life science labs, because it freaks me out. So like baby animals and fetuses and it's horrible. But they keep specimens of things, right? Now, what they put it in, it's also what they use for embalming fluid, part of it, is they use a thing called formaldehyde. Okay, formaldehyde, you would know it if you've smelt it. It smells horrific. Is an aldehyde, okay? And I remember that formaldehyde is used for dead things, and if you have a terminal disease, it's a bit macabre what I'm telling you, but it's okay. If you have a terminal disease, then you're going to die, and we say that that double bond oxygen is terminal. It's on the last carbon, so that makes it an aldehyde. Use it, don't use it. Yeah, anyway, moving on. So, next one is, it's that whole thing over here that makes that one a carboxylic acid. Please be careful here, grade 12s, because you tend to want to take a shortcut here and say, well, it's an acid. I know it's an acid, but it's very specifically a carboxylic acid because it's an organic acid. That's really important. So please don't just put acid, put carboxylic acid. Here, we actually have two halogens. So this makes it a haloalkane. Now, just to make sure you're all on the same page as me, some of you might have learned this as an alkyl halide. That's another name for them. It's the same thing, it's just another name. And then for the last one, if we look at it, well, there's only single bonds, so my last one is alkanes. Okay? We got our functional groups. That's nice, we can identify them, but that doesn't really help us very much because, well, I'm just not going to ask you to do that. We actually need to be able to name. So what we're going to need to do now is we need to go through the rules of naming, and the rules of naming are really important, and they are set out as the IUPAC rules. Now, IUPAC stands for the International Union of Pure and Applied Chemistry. This is an international system, grade 12s. You don't have a choice. You can't go, well, today I want to do it this way, today I want to do it that way. You have to do it this way, okay? And there is no leeway on this. There's no, well, you sort of got it half right, it's sort of semi-spelled right. It's right or it's wrong, okay? Because this is an international system. So the first thing you have to do, which is what we were doing up till now, is you have to identify the functional group. The functional group tells me how the name's going to end. So alkanes end in ANE, alkenes end in ENE, alcohols are OL, aldehydes are AL, ketones are ONE, etc. Okay, so this tells me how the name's going to end. So I've got to have the functional group. Then you've got to find the longest continuous chain, carbon chain. This is also known as the parent chain, and here what we're looking at is, if I have to take a pencil and draw a line from one carbon to the next, I can draw it without skipping over an empty space, and I can draw it without going through a hydrogen or another type of atom, like an oxygen, okay? That's the longest chain, and it doesn't have to be straight. It can absolutely be bent. So it doesn't have to be straight, and then we get a maximum of 8. You must learn these prefixes. Meth, eth, prop, but, pent, hex, hept, oct. Okay, you must know them. There's no way around that. They are not going to give these on your information sheet. So if you need to, and I encourage my own learners to do this, is I go, if you need to, the first thing you do when you sit down is you take your information sheet and you write down 1, 2, 3, 4, 5, 6, 7, 8, and you go meth, eth, prop, but, you write it down. So you create your own information sheet, okay? Now, once you know what the parent chain is and you know how many carbons are in it, you've almost created like a street name. This is how I describe it. Then, if there's a functional group on it, so there's a branch, which we call an alkyl group, okay, or there's a halogen, or there's a OH, or there's a double bond oxygen not at the end, we have to give it a number. It's like me saying, well, I live in 7th Street, come visit me. Would you ever find my house? No, not unless I was standing outside on the corner, but you wouldn't find my house because you need to know where my house is. You need to know that it's 322 on 7th Street, for example. So it's the same thing. We need to give it a number. But the way we number it is really important, okay? Same with our double and triple bonds. There's an order to this. First and foremost, double and triple bonds are the most important. So they take precedence. They must go on the smallest numbers. Then, substituent groups. Now, these are branches. These are little things we add to the carbon in place of the hydrogens, okay? They can be alkyl groups. They can be halogens. They can be oxygens. They can be OHs. They are still a substituent. They substitute a hydrogen. They come after the double bonds. Now here, this comes with practice because there's lots of little bits and pieces in this, but we'll get there. You can get alkyl chains, which look like alkanes minus a hydrogen, and you can get methyl and ethyl. You probably won't get propyl, okay, which would be 3 carbons, because your parent chains are too short. Absolutely can happen in the real world, but because they've narrowed it down for you that your parent chains are quite short, we can't have very long substituent chains, okay? If you have more than one of the same branch or add-on, you have to tell me. So then we start using di, tri, and tetra. Actually, we won't use penta. Di, tri, and tetra. Di means 2, tri means 3, tetra means 4. So you've all heard of tetrachloromethane, CCl4, tetrachloro, 4 chlorines, methane on 1 carbon. Okay, if there's a halogen, we change the name of the halogen to fluoro, chloro, bromo, iodo. Okay, I'd be surprised if you saw fluorine. It's not beyond it. We don't use fluorine at school level simply because the fluorines are far, far, far too reactive. Okay, so we don't tend to use them. If when you're naming, okay, and we'll get to that in a second, when you're naming, what's really important here is that when you write the name is always written in alphabetical order. So it doesn't matter what number or address you give it, you must write it in alphabetical order. That's really, really important. Okay, there's no option here. So I do have a question for you, but I just want to start with one, and then I'm going to do the first one with you, and then I'm going to leave you some time to do the rest as we go into our next break, okay? So if we look at the first one, we have 1, 2, 3, 4 carbons. Okay, so those 4 carbons tell me that if we go to meth, eth, prop, bute, so it's bute, okay, but there's only single bonds, so it's butane. All right, all one word, really, really, really important. So what we're going to do here, guys, is you've got 3 more here, and I want to give you 2 minutes, okay, and then we're going to go into a break. So you got 2 minutes to try and name these 3 for me. And the third one's a little more difficult, but I'm sure you can do it. So I'm giving you 2 minutes, and then we're going to go into a break. Well, I hope you've all managed that, but if not, it's okay. You've got the time for the break. So we're going to go to a break, and when we come back, I'm going to answer these, and then I'm going to give you a couple more just to make sure you're on the right track, okay? So we're going to take a short break, and then we'll see you in a bit. Right, grade 12. So now you've had your break. Let's see how we've done. Okay, so let's go into B, and we look at B, and we go, well, there's my longest chain from there to there. That's great, nice and easy. 2 carbons in the longest chain. There's a double bond in it. That means it's going to be F for the 2 carbons and ethene. We don't need to say where the double bond is because it can only be between those 2 carbons. Now we get to the next one, and we go, well, let's see, the longest chain is 1, 2, 3, 4 carbons. Okay, so I know it's going to be bute. And there was a triple bond over there, so I know it's going to be ine. Okay, now watch what I'm doing here. We have to say where the triple bond is, because with butane, it can actually be where it is, where we can see it now, or it can, oh, that's not an eraser, or it can be somewhere else. So watch, if we go here, ooh, I don't know what I've done, there we go, and we go, well, that's the first carbon, that's the second carbon, that's the third carbon, that's the fourth carbon. You can also number it from the other way around, so we can go 1, 2, 3, 4. So if I put a number in there, I can actually say it's either between the first and the second, or it's between the third and the fourth, and we always want it to be on the smallest number. So this one would be between 1 and 2. So we say it's but1ine. I need a number because it is possible to draw this so that instead of the triple bond being there, it's between the second and the third. Okay, then some hydrogens would disappear. If it goes between the second and third, it becomes what is known as an isomer, and it's a different compound altogether, so we have to number it. Now we get to D. Now things get a little more interesting. So now we go, okay, longest chain. Remember I said you've got to be able to take your pencil, and we go 1, 2, 3. That looks pretty cool, but there's a problem. My longest chain must include, oh, no, that's not there, that's what I want, must include my triple bond. So now we go, fine, let's go there, 1, 2, 3, 4. Now listen carefully to what I'm about to tell you. If I make 4 my longest chain, this becomes a methyl group, that becomes a methyl group. Now the problem with that is that your methyl groups are sitting on the end. They're not allowed to sit on the last carbon. All right, so that means that my longest chain must include one of those. So I know that's not my longest chain. So my longest chain must be 1, 2, 3, 4, 5. You could have gone up or down. 5 is meth, eth, prop, bute, pent. Okay, so it's pent. Great. We have a triple bond, so now we need to decide where the triple bond goes. Now we're going to look at the numbering. So we're going to go, I can go 1, 2, 3, 4, 5. So that makes my triple bond sit on the third carbon, or I can go 1, 2, 3, 4, 5. And if I go from right to left, then my triple bond sits on my second carbon. Much better idea. So that means that must be a 2. But we're not done because we have a methyl group. Now I'm numbering from right to left, so I'm going 1, 2, 3, 4. That methyl group sits on 4. Now what shall we write this? Okay, I'm actually, so we know that it's 4 methyl. Now this was just me getting the name together, and I'm going to write it nice and neatly so that you actually know exactly what it should look like. So we have 4-methyl. This is all one word, pent to ine. Grade 12s must be one word, must have numbers, must be dashes between the numbers. Okay? You ready to tackle a couple of more? A couple of more. Wow, I'm doing well. I'm going to teach you science, not English. I think it's a great idea. So, here's another 4. I'm going to give you 2 minutes. And we'll see how you, well, no, I'm going to give you 3 minutes because these ones are a little bit more complicated, especially E. So I'm going to give you 3 minutes, and let's see how you do with these ones. So off you go. All right, grade 12s, let's see how you've done. And actually, out of these four that we've got left here, E is probably the most difficult that you've got to look at. So now we look at E and we go, okay, we've got to find the longest chain. It's got to have the chlorine and the bromine in it. Okay, so we've got a chlorine over here, we've got a bromine over here, and my longest chain is going to be 1, 2, 3, 4, 5. Okay, it's not going to include that carbon because then I have to jump off places. So that means that last carbon that I've just rung is actually a methyl group. So we start at the back and we say, well, we've got 5. They've all got single bonds, so I know this is going to be pentane. All right, so that's going to be the end of my name. I've also got a methyl group, a bromine, and a chlorine. So we know it's going to be, when I write the name, I'm going to end up going bromo, and it's going to have a number. Then there's going to have to be a number for the chloro, and I'm doing this like this because I ran out of space. Then it's going to have to be a number for the methyl group, and then it can be pentane. So now we are needing to figure out where the chlorine, the bromine, and the methyl group goes. So now we look at this and we go, fine. If I number from this way, I'm going to go 1, 2, 3, 4, 5. So that means the chlorine would be on 1, the bromine is on 3, and the methyl is on 4. That doesn't look like a bad option. Let's go the other way around. And we're going to go 1, 2, 3, 4, 5. This doesn't look like a good option because this is 5. The bromine's on 3, so that's the same. And then the methyl group's on 2. So now when we look at this, we go, well, actually, the problem here is that this is 3 plus 5 plus 2, that's 10. The bottom option, if I go from left to right, is 3, 1, and 4. 3, 1, and 4 is a much better option. So this becomes 3 bromo, 1 chloro, 4 methyl. Okay? Now, ones like this one take practice. Okay? Take lots and lots and lots of practice. And also, what's important to remember with this is that your chlorine and your bromine are far more important than your methyl group. So they must take precedence. They must go on the lowest numbers, not your methyl group. Okay, so that's quite important. It's a long name. A name like this would probably be worth about 3 marks in an exam. So they do look at it in bits and pieces for you, but take your time. Make sure you get it, all right? The next one is we look at it and we go, now we've got an alcohol group, all right? So I know that it's going to end in OL because it's an alcohol. All right. Also, now I've got to get my longest chain. So I look at it and I go longest chain 1, 2, 3. 3 meth eth prop. So it's propane. The name changes a little bit here. So we go prop and then I need to say, just like I do with the double or the triple bond, where the OH is. And this one's nice because it sits on the end, so it must be on number 1. Oh, that's not a 1. I don't know what that is. That's just a little squiggle. So it must go on number 1. Okay, next one, well, here we have the double bond oxygen. Remember, it's on the end. That means it's an aldehyde. So this is 1, 2, 3, 4, 5. So that makes it pent. And from the aldehyde, we make it pentane. Because with an aldehyde, the double bond oxygen can only go on the last carbon. We don't number it. Make sure it looks like an A. Make sure that looks like an O. Otherwise, you've got a problem. And then the last one, we've got the COOH there. It's only 2 in the group. So this one, 2 makes it eth. So it's ethanoic acid, 2 words. Okay? Wouldn't it be nice if your exam could be something like this, where that's all they ask? But it's not going to be. So let's look at a question that's more like what you're going to get. Okay, so we're going to go here. Here we have 6 compounds. Okay, there's a whole bunch of questions to it. You have to do some things with it. So what I'm going to do is I'm going to give you, so there's the 6. You can see some of it. All right, I'm going to give you 2 minutes because I want to explain it as well. It's going to be quick. 2 minutes to see how many of these questions you can possibly answer. So 2 minutes, off you go. Okay, so that was very rushed, grade 12s. And remember, in exam, you'll have a lot more time than that. But I now want to show you something. Is whenever you get a question like this, and it's probably going to be the first long question in your paper, look at the table first before you look at the questions. Now, with the way this table's drawn, you are always going to have to do things like identify functional groups, identify saturated, unsaturated, identify isomers, which we'll do within a second, name things, draw things. Those are all things that are going to come up. So when you look at this and you go, well, we're not going to worry about the naming for now, but we're going to look at it and we go, well, let's identify the functional group in the series it belongs to. So A, there's a triple bond that makes this alkynes. And what I'm writing here is what I would write on my question paper. Over here, I've got an OH, so this must be an alcohol. Over here, I've got a double bond and a methyl group, but this does make this an alkene. Okay, that's a carboxylic acid because we've got its name. So we're just going to put that there. This has got a methyl group, that's okay, but that's the important one. It's on the end, so this makes this an aldehyde. And over here, there's this part, it's in the middle, that makes this an ester. Okay, so now, it says you write down the letter or letters that represent each of the following. Compound may be used more than once. First one, an alkyne. Oh wait, we've done that. Look, we identified it. It's A. We don't have to worry about it. There we go. Done. Okay. Two compounds that are structural isomers. Now, an isomer, remember, is organic compounds that have the same molecular formula, different structural formula. That means I've got to look for a compound that has the same number of carbons, etc. Now, ketones and aldehydes are isomers of each other. Carboxylic acids and esters are isomers of each other. So that means it has to be this, all right? And I know it's the pentanoic acid and the ester that I identified because I got 1, 2, 3, 4, 5 carbons in that ester. Pentanoic acid means I've got 5, so that means this must be D and F. Okay. Ooh, look, no, I'm doing funny things now. Let's go back there. Okay, that's not what I wanted to do. There we go. A compound containing a carboxyl group. Carboxylic acid must have a carboxyl group. That's where it gets its name. So that's D. And then the aldehyde, oh, look at that, that's E. And the alcohol, oh, look at that, that's B. Now, it took me a couple of minutes to work through the table, but then it takes me a second to get through the questions. All right, that's really important. Grade 12s, you have to learn the functional groups. First of all, there's going to be a question like this in your exam, 15 marks, 10, 15 marks, easy 10% of your paper. Functional groups, isomers, naming, etc. But you can't do the next section of the organic if you don't have this down. So if you don't know this, you can't do the next section when it comes to properties, and you can't do the section after that when it comes to reactions because you don't have the basics. This is your foundation. This is your stepping stone. This is where we start. So now you need to go and you need to make sure you learn this and you get it done and you practice, 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 grade 12s. Okay? Now grade 12s, next time I see you, we are, not that I'll see you, but we'll pretend I can see you through the TV. Next time, we're going to do properties of organic compounds properties, and you'll love it. Okay, so hang in there, keep studying, and I'll see you next time.